I'm with Cooler Technology to introduce CellCheck, which is our digital safety and life cycle monitoring system for batteries. I'm senior director of product development for Cooler, and I have a background in hardware and software architecture and about a 20-year history as an independent technology analyst and a market researcher. And so today we'll be covering kind of a high-level view of Cooler's holistic approach to battery safety. There's many aspects of it. And the snapshot of things that we're very familiar with. Of course, I think the technology drivers in the lithium-ion industry, and then an overview of what CellCheck is, how it works, system capabilities, architecture, and a preview of our cloud admin, the look and feel of that app. Cooler is a public corporation, has about 35 years in experience in providing thermal management technologies. Probably the most familiar or well-known success story for us is we were part of the NASA Mars rover program, actually providing battery safety in that project. As such, we bring space-proven technology combined with our total solution, that is all these elements over here, to various other platforms and various other markets. So in this diagram, you'll see the entire suite of battery safety technologies that Cooler delivers. And that includes stuff like safe battery pack design, modeling, thermal runaway testing. That means we get to blow up batteries, cell screening, safe storage and safe transportation, plus many other critical services that you need. And in particular, today we'll talk about CellCheck, which is our digital monitoring system for battery safety. So the push for higher discharge rates and higher densities is ongoing, never stops. And cell manufacturers are always moving to the next level in these categories of higher performance. And with that, the pressure is perpetual and continues to grow for public safety and for social responsibility, you might say. And we feel that that also justifies attention given to monitoring, lifecycle management, and user awareness. These are the two areas where Cooler has core key technologies to bring to the table. One is our thermal runaway shield, or S material, which is a passive safety solution for battery safety. And of course, now our CellCheck active management, which together, along with the cell manufacturers, leads us to the next generation lithium-ion battery safety solution. So let's talk about challenges in the battery industry. We all know that batteries degrade and risk increases. And each individual unique battery out there in the world has its own history, unique history of real world use and abuse. And while we may have lab data, that's one thing, but the real actual history of each individual battery is something unique. Bad things sometimes happen, and everybody wants to know always when that happens, who did what went wrong. And the missing piece is the lack of field data from the real world. Data is rarely captured or stored from the field, and even if it is, it's often inaccessible or ignored. So one of the pieces that's required is a cloud repository. Otherwise, valuable data will be lost. And that enables us to get to the point of data-driven risk analysis based on an individual battery's usage history. And after the data problem gets solved, we need a system for feedback and alerts and compliance support and tracking and reporting and best practices enforcement out there in the real world. So that's what CellCheck does. It's an active life cycle management system based on intelligent monitoring. It's what you might call digital protection for your products, the batteries, and for the consumer. It's software running on a system on a chip, which works with your BMS. And it enables a wide range of sensors and communications capability. Goal, of course, the purpose, of course, is to capture battery data, the full life history of a battery, including all electrical data, physical and environmental sensor data, and effectively then who did what when in all patterns of use and abuse for individual batteries in the field. And it keeps everything in the cloud, which enables monitoring, alerts, history analysis, health reports, life cycle prediction, risk assessment, and analytics. So what is tracked and recorded? How do we do this? Well, we can break it up. The sensor data we can break up into 4 groups. One is, of course, the battery cells themselves, also the environment, also human interaction or human access or use of the battery, And then finally, load activity. So looking at each of those individually, from the battery cell perspective, we look at discharge and charge cycles, obviously also balance voltage, temperature, stress, pressure or swelling, as it may be appropriate depending on how the pack is built, idle, storage time, cell leakage, etc. When it comes to environmental, we look at air quality, smoke. They're interesting how they apply differently. Moisture is pretty clear. Humidity is a factor. Light sensors, et cetera, which each can be set with unique trigger points. For instance, if you need to decide whether or not a battery is being used indoors or outdoors, which is a factor in understanding its life expectancy. Human access is also monitored. Any form of contact, you might say movement or change of orientation or impact or shock, which is quite vital, and vibration fits under that umbrella as well. Then there's load activity, and we just from a simple perspective, we allow some degree, an appropriate degree of monitoring of loads such as motors, pumps, inverters, lights, fans, tools, vehicles, etc. And connected with each of the events or cycles or all that history, information is attached to every action and every incident, such as, of course, time and location, user data, if applicable. And that data is stored in multiple locations. First, of course, on the chip, and second in the cloud. Plus, there are other storage options for how we do that. So let's talk about market applications. Here are 4 separate examples, each with a different set of monitoring requirements. So that would require different sensors and different goals and usage expectations of how the data is to be used. Always at the top of the list of everybody's thinking is vehicles. Which of course are always pushing for higher performance, faster discharge rates and faster charge rates. And also every fender bender is cause for concern. So we have to monitor physical impact, vibration, moisture, and temperature. And not just to analyze once or look at it every incident and individually. We have to analyze and reassess the cumulative impact of the entire life history of such events to properly interpret the consequence and or changing risk to the user in the community associated with batteries deployed in this manner in vehicles or e-mobility. Completely different, another end of the spectrum is municipal and smart city or industrial types of monitoring situations where public safety is the driving factor, the ability to monitor in real time remote status of battery-powered systems of all different varieties, user tracking, potentially unauthorized intrusion into remotely deployed battery-based systems, or telemetry for things like EV bus fleets or remote UPSs or construction sites or various types of equipment, or even energy storage sites, etc. Then another spin entirely is the energy storage system, and looking at the smaller scale commercial and home power or portable energy storage, where it's really about driving user awareness when we're getting closer to people in close proximity to these kinds of devices. Granular monitoring, event detection, cycle count, health reports, and alerts to communicate to allow the individual user to understand what's going on with his equipment. And fourth, drones, tools, and other such equipment where battery abuse is, let's just say, very common. I think that was kind of highlighted in earlier presentations. Yeah, in the space of drones, it beat the heck out of batteries, that I know. Physical impact, excessive discharge, neglect, and environmental factors all apply. So each of these requires, you might say, a different set of, sensors, or at least the type of analysis that has to be done. And we intend to comprehend all of these. And here's the sort of a complete system overview from a hardware perspective. Across the top are the communications technologies that are supported, some wired and some wireless. On the wired side, CAN, UART, and Ethernet over here. Cellular, Bluetooth, Wi-Fi, and NFC in the wireless category. So any combination of these can be supported. And we then are also integrating a wide range of sensors, which I've sort of mentioned and can be understood from the previous points in the conversation. Then on the other side of the equation, we're monitoring through the eyes of the BMS, voltage, temperature, and of course all the charge discharge cycles, balance information, et cetera, which allows us to be BMS agnostic and also battery chemistry agnostic. So whatever you got going on in your battery organization, doesn't matter, your BMS understands it, and we read that information and capture that along with all the external sources of information. Also, various tools to monitor the DC loads, whatever they may be. And so what I'll do now is I'll switch here real quick to see how can I do this. I need to switch. Let's do this. Okay, yeah, to the front end of our the dashboard for CellCheck, which is a cloud application. And here is sort of like our model city, for a deployment of a municipal system, looking at the city of Buffalo. And so there'd be various wide variety of different kinds of remote battery powered or battery backed up resources, kind of spread out, each with its own, detailed data history. Looking at the quick status overview of what's going on, problems that are reported historically over here, and a quick view of data as it's being updated. This is actually live data, but we have updates that usually occur on a like a 2-minute cycle. So perhaps there'll be an indication here on the screen of data changing, but this is the quick overview of that. Then a map to a tool to see everything at once and to pull up information on each of the deployed devices in its unique location with quick links to further information. A mechanism to provision a new device in a matter of minutes, to pump in all the appropriate information and hit submit, and a new device can be deployed. We also have a wide range of maintenance operations, which is just remote, initiating remote cycles and, test cycles and self-testing and communication testing and all that sort of stuff, along with pulling up archival data. A notification system here, let me give you a better view of that. When you go individual battery in the field, let's just say one of these systems, let's say this one needs attention, right? It's communicating too much, it's giving you too much data, it's giving you too many alerts or something like that. Well, this might be outdoors set to indoor tolerances. Okay, fine. So we'll go over here and we'll change, let's say, the air quality settings, so it doesn't trigger as so much. We change the range of sensitivity, and that can be done for all of the different data streams, all the different types of sensors that are deployed. And then, of course, in the notification system, this is where we say, all right, everybody gets notification if there's a certain type of error, or perhaps only email notifications for others. Security center, we take security very, very, very seriously. There's an edge deployment, right? There's a lot of devices out on the edge, and the security for those has to be managed. Also security for back-end access. User management, well, in this particular environment, it's not an individual user kind of a situation. We're talking about, think of city managers and asset managers of all kinds of things in the field, and you'll want to have responsibility or have visibility only to the ones that you care about, that you're responsible for. So this is where that assignment is taken care of. Analytic tools, well, we're developing all sorts of analytic tools. I won't get into that. So I think there's the kind of the snapshot of the whole thing. And I appreciate very much the opportunity. Oh, there we go. That's the reporting cycle right there. Data showing first cloud and down here as well. So I'll turn it back over, Amy, to you.